All right, so we're going to wrap up 1-6 here with introducing what's called a matrix. And so from what I've kind of heard from talking to everybody, is this is a pretty new concept, this idea of what a matrix is. So we'll define it. A matrix, the official definition is it's a rectangular array of rows and columns. In other words, it's basically a table. It's like creating a table of values, except when you write a matrix, you don't put a bunch of lines in it. So it's just sort of like a series of numbers. Matrices are extremely common in computer programming. So if you know much about that, you've probably seen these before, or especially like coding type stuff. But anyway, we'll kind of get into what this means. So it says, how can you represent this system using a matrix? So there's a couple rules about this. The first rule, number one, it has to be in standard form. So it has to be in standard form. So remember, we talked about standard form yesterday. Standard form is that ax plus by equals c. In other words, you want your x variable, then your y variable, and then equal to whatever number. So we'll do that because you'll notice none of these are in standard form. So we'll have to mess with that in a second. And then the second thing, this is the only other step, is you are then going to, once it's in standard form, you're going to write the coefficients in, and I'm going to say in a table. So I'm going to put kind of quotation marks around the table because you'll see what I'm talking about when we do it. And that's actually it. That's the entire step. You put it in standard form, and you're just going to jot down the coefficients that are there. All right, so first piece, like we said, these are not in standard form, so we need to move them around so that they are. Generally speaking, this only takes like 1 or 2 steps. So if I'm looking at this first equation, to get it in to ax plus by equals c, all I need to do is add this 2x over. So it's literally one step. When you add that 2x over, that equation would now be 2x plus 3y equals 1. That's standard form. Ax plus by equals c. Okay, perfect. Let's do the same thing with this one now. So in this case, the x is already over here, so we need to just subtract the 2y. So when we do that, keep the x as the lead term, then we'll have the minus 2y, and then equals the 10. The whole concept here is that everything's arranged in columns. You have an x column, a y column, a number or solution problem, or a column, sorry. So that's, now we're in standard form. So step 1, check, we've done it. Step 2, you're just going to write the coefficients of each of these numbers. Now remember, coefficient is just the number in front of the variable or the constant term. So matrix uses these little brackets. Sorry, they're not little. It's like a larger bracket. And then inside it, we're going to write the array of numbers. So it's just going to be 2, 3, 1. So 2, 3, 1. And then that bottom one, 4. Notice that is a negative 2. You do have to include the signs. And then 10. And that's the matrix. Every once in a while, you'll see it. Sometimes they'll put a little dashed line here to kind of simulate where the equal sign is. Not every matrix will have that. Sometimes they will, sometimes they won't. It all kind of depends on who wrote it, the text, that kind of stuff. So every once in a while, you'll see it. And this is the same thing as just basically showing you where the equal sign is. But it may or may not be there. The last line is always considered to be what it's equal to because you're putting it in standard form. Okay, and that's literally it. That essentially is almost all we're going to do today in terms of like, that's the main concept. What we're going to do our next day is we're going to talk about what do you do with this? How do you solve it? How do you actually play around with it? What's the point of doing this? And so what it is there's some programs that allow you to, once you have it written like this, to just solve problems instantly. Like you press a couple buttons and it solves the entire thing for you. So they're pretty sweet. But for today, it's basically just making sure you understand how to write the matrix. So this one, you'll notice now this is a system of 3 equations. There's x's, there's y's, and there's z's. Okay, so how do you represent this system of equations of 3 variables with 3 equations with a matrix? So we still need standard form. Now, if you have more than just x's and y's, standard form always goes alphabetically. So in this case, we need to get x, y, z, and then equal to some number. So, they basically just have standard form for linear functions, but the concept is I need to get my variables in alphabetic order, so x, y, z, and then equal to some number. That's what I need to do with all these. So if I look at this first one, let's just rewrite it. So this is x, that's fine. We have the 2y, that's fine. But notice how this first equation has no z term. if you have no z term, that means that you technically do, its coefficient is just 0. We do need to write that in there because we need this to fill our matrix out correctly. So I'm just going to kind of rewrite these so that it's in a clean format for me to see what the matrix is going to be. This one's perfectly fine. We got x, y, z, and a number. So x minus y plus 3z equals 5. So now those two are good. They're in standard form. But actually, this one is too. So we didn't have to do much here. So plus y minus 4z. So I really only had to rewrite the first equation. Probably could have just looked at that. So anyway, that's what we've got. Now, that's everything in standard form. The next step is write it as a matrix. Okay, so we're going to need 3 rows here. And it's just the coefficients. When you have a single variable, it does have a coefficient. It's a 1. So you got to go 1, 2, 0, 2. Next one's going to be 1, negative 1, 3, 5, and then 2, 1, 4, 10.
Negative 4. Negative 4.
Oh, that would help. Good call. Okay, sorry. There we go. Okay, and that's literally it. If you want to put the dashed line, you can. Generally, when they use the dashed line, they call it an augmented matrix, and when they don't, they just call it a matrix. It doesn't change anything, though. The matrix is still the same matrix. So if you see the term augmented matrix, they're just referring to, they put a dashed line to show you where the equal sign is. But it doesn't really change anything of how you're going to do or set up anything, okay? All right, last problem on here is going the other direction. So this one says, an algebra teacher creates the matrix shown to describe an exam where x is your number of 2-point questions and y is your number of 5-point questions. Write the corresponding system of equations. Okay, so you notice they give you the matrix. All we can do from this is we can use this to write the system super easy. If it's 1, 1, 19, remember this is like your x column, your y column, and then equals whatever number. So as I read this, this is 1x plus 1y equals 19. So x plus y equals 19. This equation would be 2x plus 5y equals 50. So that answers the first part of that A question. Write the corresponding system of equations. Pretty easy. Second part, what do these represent? So remember, this problem had a story to it. X is your how many 2-point questions and y is how many 5-point questions. So this one here says if x plus y is 19, that means from this equation, I know that there are 19 total questions. Okay, we don't know how many of each there are, but we know there's 19 total. This equation tells me, since there's this many 2-point questions and this many 5-point questions, that the exam is worth 50 points. So the exam is worth 50 points. And so this now, we could solve this. This problem isn't asking us to solve it, but I'm just saying we could. We have a system. We could solve it using elimination, graphing, whatever we wanted to do from here. Okay. So now the part B says, what does this matrix mean in terms of this context? So this, when you see it like this would be 1x plus 0y. So let's just write it. So we'd have 1x plus 0y equals 15, and 0x plus 1y equals 4. Or in other words, if you want to write those in much simpler terms, that would be saying x is 15 and y is 4. So this is what's called your solution matrix, or the official name for this, whenever you have this in this form, it's called a reduced row echelon, which is a fun word, form. So that's the fancy name for when they've reduced these coefficients to 1. So the way this stuff works, and we're going to talk more about this when we get to section 1.7, is when you've got one of these matrix that's set up from an equation, you can do some steps or some moves to simplify it to get it into this form, which then directly just tells you the solutions. We would now know, there's 15 2-point questions and 4 5-point questions. That's the answer to this problem. That's how you could use this to figure it out. Now, we don't know how to get from here to here yet. We'll learn that eventually. Right now, we're just learning how to write and how to read these, okay? So this is called reduced row echelon form. The way we usually abbreviate it is just the first letter of all those, RF, reduced row echelon form. So when we get to the solving part, we talk about it in 1.7, that's what we're going to be referring to. I also refer to this just as the solution matrix. It's the one that's telling you, hey, X is this, Y is this, okay? And that's actually going to be pretty much it. We're going to stop with that today. Today's all about just reading and writing matrices, which is matrices, plural of matrix. And it's probably going to feel pretty easy.